Ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I am glad you joined me this evening. Tonight's homework is for the evening of February 27th, 2018, and we're looking at more composite shapes. Let's get started. Alright, so number 16, we're looking at two rectangles. One is on top of the other. So, this is another set of superimposed shapes. The larger rectangle has dimensions of 12 by 25 feet. The smaller one has dimensions of 5 by 12 feet. Alright, so let's take a look at these two and figure out how to get that shaded region. So we know we're looking at the outer rectangle minus the inner rectangle, and if we subtract those two, we get the area of the shaded region. So we have our formulas here. No need to look in the toolbox. We use this one all the time. Length times width minus length times width equals the area of the shaded region. So 12 times 25, see that great big red outline outside that big rectangle? That's where I'm getting 12 and 25. See, that's I'm just calling that one length. I'm calling that one width. And let's see, here's my inner rectangle. Here's my length, 12 feet, and width, 5 feet, equals the area of my shaded region. And 12 times 25 is 300. Minus 12 times 5, which is 60, gives me my total area. And we're ending up with 240 feet squared as the area of the shaded region. All right, so that yellow region has a total area of 240 feet squared. All right, moving on to number 17. Number 17 looks at a real-life application of figuring out the area of multiple geometric shapes. This is the area of someone's bedroom, and it's a nice bedroom, plenty of space, and it's got kind of an L shape, or a backwards L shape. So the first part of this question looks at the number of square feet we need for coverage. So here are our two rectangles, a large rectangle and a smaller rectangle, and the other shape that makes up this bedroom is a triangle in green. So again, we have our two rectangles and a triangle in green. All right. If we find the areas for all three of those shapes, we end up with the total area. So let's grab our formulas. All right, so we have length times width for our large rectangle plus length times width for our smaller rectangle plus 0.5 times base times height equals the total area. We could also say base times height divided by 2. For me, it was easier to type 0.5 times base times height. So let's back out a little bit and give us some space. All right, so we know what our formulas are. Moving on to filling in the blanks. The large rectangle has a length dimension of 10 feet. The width here I'm calling 11 feet. And I forgot my parentheses, but that's okay. 10 times 11, that's going to give me the area for that first large rectangle. Then we have the smaller rectangle. 10 times 6. Our length is 10, our width is 6. Now we add that to the area dimensions for our triangle. We have 12 feet as our base, and we have 8 feet as our height. And if we do the math here, we will end up with the total area. So what do we do next? 10 times 11 is 110. 10 times 6 is 60. And 12 times 8 is 96. And if we add 110 plus 60 plus 0.5 times 96, we will get our total area. All right, 110 plus 60 is 170. And 0.5 times 96, or half of 96, is 48. Add all that up, we get 218 feet squared. And that's the total area for this particular bedroom. Now we know how much carpet to buy. The second piece of this problem is where we look at the perimeter around the figure. And you all remember from first and second grade that when we look at perimeter, it's always the distance around the figure. And when the problem says we're laying baseboards, you know those flat pieces of wood you see at the bottom of all the walls? Well, those are called baseboards, and they run usually all the way around the room. So when they're talking about how much will we need to buy, as far as how many baseboards do we need, how many feet worth of baseboards do we need, we're talking about perimeter. So our strategy is just add those outer line segments together. You'll notice I added 2 measurements there, and I'll tell you why when we get to them. All right, so we have a starting place here of 10 feet. So that's our first wall. 10 feet plus 11 feet, plus 12 feet, plus 6 feet, plus 10 feet, plus 6 feet. Now, here's my first stopping point. Do you see why I call that wall 6 feet? It's because that 6 is parallel to the wall across from it, and it's the same measurement. All right, so add another 6 feet there, and plus 11 feet. Again, because that 11 comes from the 11 that it's across the room from, okay? That's the top of the rectangle. The other 11 feet is the bottom of the rectangle. So if you add all that up, you get 66 feet. That's it. Y'all take care, and remember, math is not just about numbers, it's about the relationships that surround us every day. Have a good one.